NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics video. Today, we are going to learn how to solve some quadratic equations using the concept of binomial products. The key to solving these types of problems is understanding that a quadratic expression can be written as a product of two binomials. Let's look at the general formula x squared plus a plus b times x plus a b equals x plus a times x plus b. This formula works because when we multiply two binomials, we get a quadratic expression. Let's verify this by multiplying out the right side x plus a times x plus b. First, we multiply x by x to get x squared. Then we multiply x by b and a by x to get bx plus ax, which is x times a plus b. Finally, we multiply a by b to get ab. Putting it all together, we get x squared plus a plus b times x plus ab, which is exactly what we have on the left side. Let's work through an example using this formula. Solve the quadratic equation x squared plus 5x plus 6 equals 0 using the product of two binomials method. Let's solve this step by step using the algorithm we've learned. First, we need to identify the values in our equation that match our standard form. Looking at our formula, x squared plus a plus b times x plus ab, we need to compare it with our problem x squared plus 5x plus 6 equals 0. Looking at our problem and comparing it to our formula, we can see that a plus b must equal 5 and a times b must equal 6. We need to find two numbers whose sum is 5 and whose product is 6. Now that we've found a equals 2 and b equals 3, we can write our quadratic expression in factored form. Using our formula, x squared plus a plus b times x plus a b equals x plus a times x plus b, we get x squared plus 5x plus 6 equals x plus 2 times x plus 3. Now that we have our equation in factored form, we can set each factor equal to 0 and solve for x. Remember, if a product of factors equals 0, then at least one of those factors must be 0. So we have x plus 2 equals 0, which gives us x equals negative 2. And x plus 3 equals 0, which gives us x equals negative 3. Therefore, the solutions to the equation x squared plus 5x plus 6 equals 0 are x equals negative 2 and x equals negative 3. Let's summarize what we've learned today. We will solve a rational equation step by step, following the exact algebraic sequence shown in the reference method. Here is the problem. X plus 3 over x minus 1 equals 4 minus x over x minus 1. We will mirror the reference steps exactly. Multiply by the common denominator, expand, simplify, factor, then solve. Step 1. Multiply both sides by the common denominator, which is open parenthesis x minus 1 close parenthesis. After canceling the denominators, we get this simplified line. Now expand the product open parenthesis x minus 1 close parenthesis times open parenthesis x plus 3 close parenthesis, then bring down the rest. Combine like terms and move everything to the left side to make it 0. Now apply the standard factoring pattern to make it 0. Now apply the standard factoring pattern. X squared plus the sum of plus b times x plus a b equals open parenthesis x plus a close parenthesis times open parenthesis x plus b close parenthesis. We choose numbers a and b whose product is negative 4 and whose sum is 3. A good choice is a equals 4 and b equals negative 1. That factors the quadratic as. Set each factor equal to 0 and solve. Finally, check the original domain. Because the denominator contains x minus 1, x equals 1 is not allowed and must be rejected as an extraneous root. The valid solution is x equals negative 4. The solution is x equals negative 4. Let's write the problem. Step 1. Multiply both sides by the denominator 1 plus square root of x to clear the fraction. Step 2. Expand the right-hand side using distribution. Step 3. Bring like terms together to isolate the radical term. Step 4. Square both sides to remove the square root. Step 5. Expand the square and simplify to get a polynomial equation. Step 6. Factor out x. Then factor the quadratic using the standard product sum pattern. Step 7. Read the solutions from the factors. Step 8. we must check for extraneous roots introduced by squaring. Substitute x equals 4 into the original equation. Therefore, the valid solutions are x equals 0 and x equals 1. Here is the final answer. 0 and x equals 1. Here is the final answer. And x equals 1. Here is the final answer. Example. We will solve this rational equation step by step, following the exact algorithm shown. Our equation is 5 over x minus 4 over x times x minus 2 equals x minus 4 over x minus 2. We will also remember that x cannot be 0 and x cannot be 2 because those make denominators 0. Step 1. Set the equation equal to 0 by moving everything to the left side. Step 2. Combine the fractions using the common denominator x times x minus 2. Step 3. Expand the numerator and collect like terms. Step 4. Combine like terms to make a single quadratic expression. Step 5. Multiply both sides by -1 to make the leading coefficient positive. Step 6. Factor the quadratic. We recall the pattern x squared plus a plus b times x plus a, b equals open parenthesis x plus a close parenthesis times open parenthesis x plus b close parenthesis. For our numbers, a equals -2 and b equals -7. Step 7. Apply the zero product property by setting each factor equal to 0. That gives x equals 2 or x equals 7. Step 8. Check the domain. Because the original denominators were x and x minus 2, we must exclude x equals 0 and x equals 2. Therefore, x equals 2 is not acceptable. The only valid solution is x equals 7, 0, and x equals 2. Therefore, x equals 2 is not acceptable. The only valid solution is x equals 7. Here is our example in bold orange. First, identify values that make a denominator 0. Notice m squared minus 4 factors into left parenthesis, m minus 2 right parenthesis left parenthesis, m plus 2 right parenthesis. So the domain excludes m equals 0, m equals 2, and m equals -2. Step 1. Move every term to one side, so the equation equals 0. We'll subtract the right side from both sides. Step 2. Use the least common denominator to combine the fractions. Since m squared minus 4 equals left parenthesis, m minus 2 right parenthesis left parenthesis, m plus 2 right parenthesis, the least common denominator is m times left parenthesis, m minus 2 right parenthesis times left parenthesis, m plus 2 right parenthesis. Multiply each term by the common denominator and simplify. Step 3. Expand the numerator carefully. 3m times left parenthesis, m minus 2 right parenthesis becomes 3m squared minus 6m. 2 times left parenthesis, m minus 2 right parenthesis left parenthesis, m plus 2 right parenthesis is 2 times left parenthesis, m squared minus 4 right parenthesis. Finally, minus m times left parenthesis 4, m minus 4 right parenthesis is -4m squared plus 4m. Step 4. Combine like terms to form a simple quadratic. That gives m squared minus 2m minus 8 equals 0. Step 5. Factor the quadratic using the product sum pattern. Recall, x squared plus open parenthesis, a plus b close parenthesis, x plus a b equals open parenthesis, x plus a close parenthesis open parenthesis, x plus b close parenthesis. Here, numbers 2 and -4 multiply to -8 and add to here, numbers 2 and -4 multiply to -8 and add to -2. So the factorization is left parenthesis m plus 2 right parenthesis left parenthesis m minus 4 right parenthesis equals 0. Step 6. Solve each factor equal to 0. M plus 2 equals 0 gives m equals -2. M minus 4 equals 0 gives m equals 4. Step 7. Check the domain restrictions. M equals -2 is not allowed because it makes a denominator 0. Therefore, the valid solution is m equals 4. Here is the problem. We must solve for t in the equation, left parenthesis t minus 1 right parenthesis over t plus 4, minus 2 over t minus 4 equals 7 over 6. First, state the domain restrictions. Denominators cannot be 0, So t plus 4 is not 0, and t minus 4 is not 0. That means t is not equal to negative 4, and t is not equal to 4. Step 1. Move every term to the left side, so the equation equals 0. Step 2. Clear denominators by multiplying both sides by the least common denominator, 6 times t plus 4 times t minus 4. This removes the fractions in one move. Step 3. Expand the products. First, t minus 4 times t minus 1 equals t squared minus 5t plus 4. And t plus 4 times t minus 4 equals t squared minus 16. Now distribute the coefficients and simplify. Step 4. Apply the factoring pattern x squared plus a plus b times x plus a b equals x plus a times x plus b. We need two numbers that multiply to negative 88 and add to 42. They are 44 and negative 2. So the quadratic factors as t minus 2 times t plus 44 equals 0. Step 5. Set each factor to 0 and solve. T minus 2 equals 0 gives t equals 2. T plus 44 equals 0 gives t equals negative 44. Finally, check the domain restrictions. T cannot be 4 or negative 4, and our solutions are 2 and negative 44, so both are valid. Therefore, the solutions are t equals 2 and t equals negative 44. So both are valid. Therefore, the solutions are t equals 2 and t equals negative 44. Example: we will solve the quadratic equation by factoring, exactly following the given step order. Our problem is 4x squared plus 3x minus 1 equals 0. Step 1. Rewrite the middle term by splitting it. 3x becomes 4x minus x. So we have 4x squared plus open parenthesis 4x minus x close parenthesis minus 1 equals 0. Step 2. Group the terms for factoring. Open parenthesis 4x squared plus 4x close parenthesis plus open parenthesis negative x minus 1 close parenthesis equals 0. Step 3. Factor each group. From the first group factor 4x, from the second group factor negative 1. That gives 4x times open parenthesis x plus 1 close parenthesis minus open parenthesis x plus 1 close parenthesis equals 0. Step 4. Factor out the common binomial x plus 1. We get open parenthesis x plus 1 close parenthesis times open parenthesis 4x minus 1 close parenthesis equals 0. Step 5. Use the zero product property. Set each factor equal to 0 and solve. X plus 1 equals 0 leads to x equals negative 1. 4x minus 1 equals 0 leads to 4x equals 1. So x equals 1/4. Therefore, the solutions are x equals negative 1 or x equals 1/4. In this lesson, we will solve two equations exactly following the shown algorithm. We will display each line in the precise order and explain why every move is valid. Example: start with the equation x minus 1 times x plus 1 equals x minus 1. We will now mirror the algorithm line by line. Step 1. Subtract the right side from both sides so that the equation equals 0. Step 2. Factor out the common factor x minus 1 using the distributive property. Step 3. Simplify the bracket x plus 1 minus 1 becomes x. Step 4. Apply the zero product property. Set each factor equal to 0 and solve. Example: now follow the second algorithm sequence exactly as written. 5x cubed minus 5x squared minus 10x equals 0. First, factor out the greatest common factor 5x. Next, factor the quadratic x squared minus x minus 2 as x minus 2 times x plus 1. Finally, use the zero product property and solve each factor equal to 0. Summary: we followed the algorithm exactly as written. Move all terms to one side, factor step by step, then apply the zero product property. Our solutions are x equals 1 or 0 for the first equation, and x equals 0, 2, or negative 1 for the second. Great work following the precise structure. In this lesson, we will factor a quadratic with large coefficients using the split the middle term algorithm, exactly in this order. Show the expression, multiply a and c, find two numbers, split the middle term, group, factor each group, and then factor the common binomial. We want to factor the quadratic expression shown. Step 1. Multiply the coefficient of x squared, 5, by the constant term, 54. So 5 times 54 equals 270. Step 2. We split the middle coefficient 93 into two numbers whose product is 270 and whose sum is 93. Those numbers are 90 and 3, because 90 times 3 equals 270, and 90 plus 3 equals 93. Step 3. Rewrite the quadratic by splitting the middle term into 90x plus 3x. Step 4. Group the first two terms together and the last two terms together. Step 5. Factor two terms together. Step 5. Factor out the greatest common factor from each group. From the first group, we factor 5x, and from the second group, we factor 3. Step 6. Notice the common binomial x plus 18. Factor that common binomial to finish. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.